Hello students, welcome to real numbers in 10th grade. And in this video, I'm going to discuss about Euclid's lemma, very important auxiliary theorem in arithmetic and also number systems. Let's get into the details of it. First, let's read it. I have already underlined some important statements here. Euclid's lemma, given two natural numbers, capital D and small d. I'm taking capital D is a bigger number, small d is a smaller number. There exists a unique natural numbers small q and small r such that this relation is valid. This is called Euclid's lemma. Capital D equals to q times small d plus r, where this r lies between 0 and d. And this capital D is called dividend, D is divisor, and q is quotient, and r is remainder. So to understand this statement, let us take an example. Let's see 29 by 7, I want to calculate here. So first what we will do is, we'll do the division. Let's say 7 and 29. We'll do the division here. So 7 is called divisor, this is small d. And 29 is called dividend, capital D. So if you run this seventh table, 7 fours are 28. 7 fours are 28. And this 4 is called quotient. And if you take the difference, what you get is called remainder. This is smaller remainder. So what this equation says is that capital D, which is 29, the dividend, is equal to q times, q is the quotient, 4 times divisor, small d, which is 7 here, plus a remainder, that last number that you get at the end. See whether it will be satisfied or not. 4 sevens are 28 plus 1, 29. 29 equal to 21. That's what it says. So this relation says that whenever you are dividing, you would get a remainder. This is a remainder that you get. This small d is the one with which you are dividing, and q is the one that you get on top of this division that you get here. So let's take few more examples to understand this statement a little more. Let's take another example, 38 by 12. So first let us calculate the value, 38 by 12. 12 you take here and 38 is here, and 38 is called dividend, capital D, and this 12 is called divisor, small d. You run the table, 12. 12 threes are 36. 12 threes are 36. So when you take the difference, you get 2. This is the remainder. This is smaller. And this 3, what you get is called quotient. So if I have to write that lemma again, what it says is that capital D equals to q times small d plus r. Capital D is the dividend here, that is 38, equals to q is 3 times the divisor, that is 12, plus remainder, that is 2 here. See whether it is satisfied or not. 12 threes are 36 plus 2 gives you 38. So this is what. So whenever you have a division, accordingly you can write this equation where q, in this case q is 3 and r is 2. These two are uniquely decided. Unique. You don't have any other possibility. They are decided for a given values of capital D and small d. This is capital D and this is small d. Q and R are uniquely decided. That's what it says. Let's take another example. 51 by 9. Let's do the division of it again. You have 9 and then 51. So 9, you run the table. 9 fives are 45. You take the difference, you get 6 here. And so this 9 is the divisor, small d. This 51 is capital D, dividend. And this 5 is the quotient, and this 6 is the remainder. This 6 is the remainder here. Again, let's write that equation. Capital D equals to q times small d plus r. Capital D is the dividend, which is 51 here. That is equal to q times, that is the quotient. Quotient is 5 times the divisor, which is 9 here, plus the remainder that I get is 6. See whether it is satisfied or not. 5 nines are 45. 45 plus 6 equal to 51 that you have here. So the same idea. This is the idea of Euclid's lemma. And we can also write this Euclid's lemma in an alternate way. Let's try to understand that. We already got that capital D equals to Q times small d plus R. This is Euclid's lemma. To write it in an alternate form, what you do is just divide it with small d either side. You divide with small d either side. And after that, you split it QD upon D plus R by D. And you see DD gets cancelled out. So what you get is capital D by small d equals to Q plus R upon D. And this is the form that I'm showing here. So dividend divided by divisor equals to quotient plus remainder by divisor. This is the formula that you have here. So just to write it in that form, let us take example 59 by 6. Run the 6th table. So 6th table, 6 and 59. 6 9s are 54, 6 10s are 60. It is between 54 and 60. So 6 9s are 54. So you get 5 as a remainder. So if I write this, what I can do is, whatever 54 I'm getting, this 59 can be split as 54 plus 5. 54 is the multiple of 6, very close to 59. And then whatever is excess that you have, that is remainder, you write it like that. Whole divided by 6. That's what we can write. Now you can split it into two ratios. This is equal to 54 by 6 plus 5 by 6. 54 by 6 is 9. 9 plus 5 by 6. And that is what you get. This 9 is a quotient. You see here, 9 is a quotient. So you can do the division either this way, or you can write it like this in a split form like that. And whatever you are getting in the end, 5, that is a remainder. That is 5 you get here. Remainder is 5 here. You can match it. That 6 is a divisor. 6 is the divisor that you get here. That's what I have. This is another way of writing it. Let's take few more examples in the same lines to understand it better. Take another example, 40 by 12. So you run the table 12. 12 3 is the 36. 12 4s are again 48. So it is more. You take 36. That is the closest value of that multiple of 12 to 40. So we can write 40 equals to 36 plus 4. Why did I write 36 plus 4? Because 36 is the multiple of 12, closest to 40. So if I write that here, 36 plus 4 divided by 12 and then split it into two ratios, 36 upon 12 plus 4 upon 12. 36 by 12 is 3. 3 plus 4 by 12 is what I get. So what it says is that this is dividend, yes, capital D, and this is divisor, small d. And whatever 3 I'm getting, this is a quotient. And then this 4 is a remainder here. So this is another way of writing it. You can go back and check this relation. D by D equal to Q plus R by D. That's what you have here. Right, another example, 77 by 8, let us take it. First do the division table, let's run the table. 8 9s are 72, 8 10s are 80. So this 77 is between 72 and 80. You take the smaller one, smaller multiple, closest to 77. So I can write 77 as 72 plus 5 divided by 8 as it is. Did you understand why we have written 72? Because that's a multiple of 8, very close to 77. And you can split it into two parts, 72 by 8 plus 5 by 8. 72 by 8 will give you quotient. First term will give you quotient. 72 by 8 is 9 plus 5 by 8. This is what I get. 77 by 8 equals to 9 plus 5 by 8. If you look at the relation that you have, capital D by small d equals to Q plus R by D. You can see capital D is 77, small d is 8 here, and Q is 9 here. That's a quotient that you get here, and 5 is the remainder. So this is another way of writing the Euclid's lemma there. I hope you understood that. Thank you very much for joining. For more exciting of this kind of videos, we'll get back to you soon. Until that time, thank you. Goodbye.